All right, so I would like to demo a little bit, but there will be some remaining detail that should be done by you, also exercise. But let me know if you have trouble doing it. So there are two places you can find what I'm trying to do here. One will be on slide 54 on your OO review slides. So this is about point array. In your Lab 0 Part 2, I believe you're doing a product array, right? It's similar programming pattern. But I think I would just like to do a simplified version of the demo so it can just get you motivated to really get started. So this pattern here is actually going to be used for your subsequent labs and also for your programming tests. So it's really important to get it understood. So on the slides, you will see some code fragment over here. Right. I'm not sure why this is a blackout, but OK, anyway, came back. So this is really the code. I put it onto the Eclipse. I'm going to make the code available to you. So today, we don't really type anything. I just want to do some tracing on the paper and also on the debugger as well. So you can also do the exercise yourself. You can find slide number 54. And if you see there's a link at the bottom there, so if you click on that, that one is one of the PDFs you're supposed to read. Right? That's something I made available to you since day one of the course. So make sure you study that. It's going to be very beneficial for later. And specifically, I want to talk about PointCollector over here and also how we can understand at a higher level about this method here, which will return an array of objects. This is also some method you will be expected to do in the labs and also in the test. All right, let's now talk about it. So what's really the idea? If I switch to iPad. So this code over here, you can find on the slides, right? Nothing has been changed, but I'll get to it. And this will be the JUnit test that is going to test for the correctness of the method over here. getPointsInQuadrantI number 1. But I'll explain that in a moment. Right? The idea will be we create some PointCollector objects. And then we are going to add 1, 2, 3, and 4. 4 points into the collector. And then we're going to call this accessor method here, accessor because we can store the return value into another variable. Okay? And then once we get this return value here, we're going to make sure the length of the return array is going to correspond to how many points are actually in quadrant number 1. All right? And then we're going to do some checks over here. So what I would do is, let me just sketch at a high level about how this method will work. It's a little bit sophisticated, but it's not too bad. That's something you might also find useful when you implement your lab methods. Let's talk about this. Okay. Before we dive also into the debuggers as well, but let's now sketch. Okay. What's going to happen is we first of all going to create a PointCollector PC. And it's going to have a piece PointCollector objects. So PointCollector. And there are two attributes here corresponding to the programming pattern. If you recall, the PointCollector got the points array and also NOP. Right? In the beginning, we're going to initialize that to be 100 from index 0 to index 99. So after creating this object, we're going to have the number of points, the integer counter will just be 0. No points has been stored. And also the points array. And this one here is going to point to the beginning of an array of size 100. 0, 1, 2, 3, etc. Up to 99. Size 100, right? In the beginning, what should be the value for every slot? Should be the default value, null, right? For reference type. Let's put it. Null, 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 null. Null throughout. And the pattern is going to work this way. Every time you want to add a new points into the PointCollector, you're going to start with the leftmost null slot. You go from left to right. You don't really jump the slot. If you somehow jump the slot, there's some error in your programming pattern. So let's say after the first one, after the first point, it's going to be 3, 4. Right? That's the first point to add. So it's going to be something like this. We're going to say this index over here, that's a leftmost null slot. Rather than pointing to null, is now going to point to a new points over here. And then that points is going to be 3, 4. And then we got x and y, and then 3 and 4. At the same time, we should also update the counter to be 1. That's really the conceptual idea for this programming pattern. Every time you want to add a new object into the collection, you want to make sure there are two things you do. Number one, you want to make sure the leftmost null slot is now pointing to that particular object. At the same time, you should also keep this integer counter in sync. You want to do both of them. So a possible test question could be, I might just give you a wrong implementation for the programming pattern. For example, I might say, I don't really update this integer counter. What will be the consequence? Right? Something like that. So you really want to understand thoroughly this programming pattern. Right? And let me do a little bit more idea sketching, and then we can look at the debugger briefly. Okay? That will be the demo. So let's say we do the remaining 3 points, 1, 2, and 3. Let's do that quickly. So the second point I want to add, let me just copy this. So the second point is going to be a second object over here, but it's going to be, let me just copy this one here, so I don't need to draw again. Okay, so the second one is -3 and 4. Okay, so -3 and 4. So number one, we want to make sure the leftmost null slot, it will be 1. And the 1 here also corresponds to the current value of NOP, right? That's also explained in the tutorial. Rather than pointing to null, it's now going to point to here. At the same time, we're going to change the value from 1 to 2. All right, one more. Let's do all the 4 points. And the third over here is going to be -3 and 4. -3 and 4. -3 and 4. So let it point to here, and then update from 2 to 3. And the final one, 3 and -4. So here, another points over here, 3 and -4. And rather than pointing to null over here, and update from 3 to 4. And the 4 over here is telling you if I want to add a 5th point, I should store that at index 4. Right? You keep going until we reach the end. Okay, that should be quite conceptually clear. Now, what do we want to do? Out of all these 4 points, if you just want to have this visualization here, let's say x and y, we basically got 3, 4. We got 3 -4. We got -3, 4. And also we got -3, -4. We want to collect all the points that are in quadrant number 1. At the moment, it's only 1 point. What we ultimately want to return for this method over here would be, since we only got 1 point that's in quadrant number 1, which is over here, what we want to return is something like this. We want to return an array, as you will see in the method here, it's called Q1 points. That's a local variable. So we want to say Q1 points is going to point to an array of size 1 only size 1, because there's only 1 point in the quadrant 1. And then index 0 is actually going to point to the quadrant 1 point, which will be this particular point. That's what's going to happen, all right? And then this will be to return. That's why you will see that at the end over here. But how is this going to occur, right? Let me sketch the intermediate step a little bit for you, okay? Let's say at the moment our point collector has 4 points in total, right? So the NOP is simply equal to 4. You want to program your method in a very general way to accommodate all the possibilities. So in order for me to return this precise size of the array, I need to do some intermediate steps to really prepare me. So in general, what will be the maximum number of points that can be in quadrant number 1? It'd be 4, if all the points are in quadrant 1. So what I do is, you will see in the method, there is another intermediate variable, it's called PS. And that one there simply got this.NOP. That tells me, let's create an intermediate array first. Okay? So what I would do is, I got something called PS And then that one there has 4 points, 4 slots, 0, 1, 2, and 3. All right? And then this loop over here is very important. This one here basically is trying to figure out how many Trojan 1 points do I have. So that's why you see an integer counter over here. This one is going to record the number of Trojan 1 points. And I will let you study this for loop in detail. That one is pretty straightforward. You basically just go over this particular array one by one. If this current point you're looking at is enclosure number 1, meaning that x is larger than 0, y is larger than 0, the count is going to be incremented by 1, right? You just keep going. So after that, you're going to, at the end of this particular loop, count is going to be incremented to just 1, because there's only 1 points, which correspond to this point over here. That's enclosure number 1, right? So you will get count is equal to 1 at the end. And what about the remaining method? The remaining method is we're going to initialize this Q1 points array that we're going to return. So that's exactly over here. We're going to initialize it to be of the size just corresponding to the count and then copy over the point, right? So what I really want you to dive deeper later on your own is to understand, number one, this is the array that we are keeping privately for the point collector, number one. Number two, we start with the pessimistic view to say we may have up to 4 Trojan 1 point to start with. And number three, we have the loop to figure out we only got 1 Trojan 1 points. That's why we have to initialize this array accordingly and copy over the point address. Right? So these are the 3 points for you to keep an eye on. And I would like to do just one more demo here to see how we can verify the different steps over here in Debugger. Right? That's also something you want to also try. Let me just do a few. Okay? I'm going to make the source code available to you as well. You can just import it to your Eclipse and play with it. And if you really want to practice, one way to practice would be, let's say once you believe you're understanding everything about this Q1 points method, what you can do is you can simply delete the implementation over here, for example, and then try to reprogram that yourself, maybe in your own way or maybe based on how you understand it. Only that you will actually be convinced you can really do it. Okay? That's something I'll leave to you. Okay? I want to just put a few breakpoints just to show to you. How about this? Let's do the easy one. If I go to the JUnit test over here, and then let's put a breakpoint here, line number 14. Okay, let's do that first. Let's see exactly how the constructor is going to initialize the point collector. Let's get convinced on that. So I'm going to launch the debugger. And then, okay, switch. And we're going to pause at line number 14 over here. Yep, we're here. Right? At the moment, PC has not been created yet. What we can do is we can step into. If we step into, we're now in the constructor of this particular point collector. And notice that we didn't initialize NOP explicitly to be 0, but that's okay, because it's going to take the default value 0. So it's going to work. But if you really like, it's totally okay if you want to write explicitly this.NOP equals 0. Maybe that's also what I did in the tutorial in the written notes, but it'll be up to you. Let's try this. If I step over and step over, all right? Now let's verify what's happening here. If you go under the current object, you can see we've got NOP. That is 0, right, in the debugger under variables. And points over here is interesting. If you expand it, you see you got index 0 and up to index 99, right? That's exactly what I showed to you earlier on the iPad, right? To say in the beginning, we got from index 0 all the way to 99. They're all null. Right? So you really want to verify what's really happening there at the runtime correspond to how you understand it at a high level. It's very good for your understanding. Okay? Let's do one more. So that's about initializing the point collector. What I want to do now is to say here, all right, why don't I put another breakpoint? Let me just cancel this. Let me launch another session. Let's say we do at line number, let's say 29. So this will be the point right after all the 4 points have been added. Why don't we do that? And then I'm going to launch the debugger. And then let's see. All right, so now I'm here in line number 29. So this is after I have added all the 4 points over here. And what's going to happen here? If you expand PC, the point collector, you can see NOP now is 4. We got 4 points. And then if you look at the array, what do you expect to see? Well, since we got 4 points already added, so now you can see index 0 up to index 3. We got addresses over there because we're storing the points. But starting from index 4 all the way until index 99, we still got none. All right? Now, what would be an exercise for you? Let me tell you what you should really try on your own. And let me know if you got trouble doing it. I would suggest the following. You can now cancel this breakpoint over here. I want you to put a breakpoint at line number 29 over here. So once you reach this point over here, I want you to step into getPointsInQuadrant number 1. Step into it. So that's going to bring you to getQuadrant 1 over here. Now, I want you to somehow really try to see how the various variable, especially PS and also count, is going to change as you try to execute a loop, execute different lines. That can really help you understand how the algorithm actually work for this method here. All right? And then eventually you will want to see the Q1 points over here really correspond to this array over here of size 1. That's really what we're going to return at the end. So that'll be the exercise for you. This might just take maybe 10 minutes, 15 minutes to do this exercise, but it's definitely going to help you a lot. You are going to, again, implement similar methods for Lab 1 and Lab 2 specifically. That's kind of to this complexity. So I would say invest some time right now. That can make it easier for you. Okay. Any questions about this programming pattern here? Not too bad, huh? So later on, for your programming tests and labs, you will only be allowed for use primitive array for collection purpose. You cannot use any array list or linked list. I really want you to try building up everything from scratch. All right. All right, thank you. And then keep working on your Lab 0 Part 2.